Welcome, everyone. Thank you for joining us for the 8th INA NAK workshop under the theme of Driving Innovation Together, AI and Semiconductor for a Smarter Future. This is Haejong Jeon at LG Electronics Artificial Intelligence Lab. I'm very pleased to host the first day of this workshop. This workshop is co-organized by National Academy of Engineering of Korea and Indian National Academy of Engineering. Honorable members of two academies and related experts in India as well as in Korea are participating in this workshop online. AI technology is rapidly being applied to smart manufacturing. Both Korea and India have been recognized for the lighthouse factories by World Economic Forum. And I'm excited for the opportunity to share our insights and explore potential collaborations. We are honored to invite the president of both academies to deliver welcome remarks. First, it's my great honor to introduce Professor Eui-jun Yoon, President of the National Academy of Engineering of Korea. Please give him a warm round of applause.
Ladies and gentlemen, good morning and good afternoon. It's a great honor to welcome all distinguished participants from India and Korea to the 8th INAE NAK workshop. Since 2017, the National Academy of Engineering of Korea and the Indian National Academy of Engineering have worked together to build a trusted platform for academic and industrial cooperation. Despite many challenges and changes in the global environment, our partnership has remained strong and resilient. I would like to express my sincere appreciation to INAE for your continued support and valuable contributions to this workshop. In particular, I wish to thank Mr. J.D. Patil for his leadership and encouragement. This year's theme, Driving Innovation Together, AI and Semiconductor for a Smarter Future, is both timely and forward-looking. Korea and India are natural partners in this critical area. Korea possesses world-class capabilities in advanced manufacturing, while India is emerging as a global leader in digital innovation and chip design. As a global supply chain shift and as demand for technological independence grows, both our countries are striving to build stronger and more collaborative innovation systems. The global semiconductor market is projected to reach nearly $690 billion by 2025. A significant share of this growth will be given by generative AI. AI-specific chip alone may account for more than $150 billion, highlighting the urgent need for expanded innovation capacity and production capabilities. This also underscores the importance of strengthening the link between design and manufacturing, as well as building stable and resilient supply chains. Korea and India are uniquely positioned to work together in these areas, aligning policies and investing in complementary strength to develop a robust and diverse semiconductor ecosystem in the Indo-Pacific region. Recently, Prime Minister Modi welcomed a special delegation from Korea and emphasized the need for deeper cooperation in key sectors, including semiconductors. This year's is particularly meaningful as it marks the 50th anniversary of diplomatic relations between our two nations and the 10th anniversary of our special strategic partnership. This is a timely opportunity to reaffirm our shared commitment to advancing industrial, technological, and strategic collaboration. In light of these developments, I hope today's discussion will generate very practical insights and innovative ideas to strengthen corporate corporations in AI, semiconductors, and their applications across aerospace, mobility, and advanced manufacturing. By briefing our strategies, no, no, by refining our strategies and by combining our expertise, Korea and India can work together to build a smarter, more sustainable future, founded on trust, innovation, and shared progress. Thank you once again for joining us, and I wish you have a productive and inspiring workshop. Thank you very much.
Thank you, Professor Yun. Then I'd like to invite the President of the Indian National Academy of Engineering, Mr. J.D. Patil. Please welcome.
Thank you so much, Professor Yoon. It's my pleasure to see you present here, and hopefully we shall be seeing you soon, exactly about 3 weeks, 3.5 weeks from now in Australia. Dignitaries, esteemed guests, distinguished speakers, ladies and gentlemen, on behalf of INAE, it is my absolute privilege to welcome you all to this landmark. And as our earlier speaker mentioned, it's exactly the eighth such seminar, and it's a strong relationship that we have been continuing for now 9 years. This is a program specifically talking of semiconductors, AI, smart manufacturing. And when we talk of that, the leadership of Korea becomes extremely important. And as I have always been saying on the lighter side, when we talk of India and Korea, each one Korean and 25 Indian make a team of 26. And this is the power of our coming together and doing things together. Today, as a result, it marks a very significant step forward in our partnership as Asia's the most dynamic economies, united by a vision of future manufacturing innovation through cutting edge technology and blessed by our leadership in both the countries. India, has a very, very clear look east policy, and so is Korea in terms of relationships within the Asian region. And this is essentially a relationship that has a lot in store to take our countries as well as this region forward. All of us know the center of gravity of the world GDP used to be in this region 2000 years back. It remained in this region till about 400 years back, gradually moved towards west, and we know it is already shifted within this region. And as we all grow, it is going to be further shifting to the right and towards the Asian peninsula. And this is essentially where our relationship is an extreme important aspect of how the world economy will behave and how our countries can get the most out of that. As the only Academy of Engineering in India, as I mentioned, we'll be soon going to Cates in Australia, and we look forward to seeing you there. Various activities under Cates that we have been doing is this Academy's meetings as well as special events and seminars together between Korea and us. It began in 2017 in the form of joint workshops. And I must thank Professor Yoon that every year, whenever India has proposed a kind of a seminar, we have debated, we have discussed, finalized it very quickly, and it has been an amazing relationship in terms of what we have seen and going forward. I can only just mention that these 8 years have been on different subjects. I recall the first one in 2017 was about high temperature materials and critical applications, and specifically aircrafts, rocketry, nuclear energy, thermal plants, rocket vehicles, chemical processing plants. The 2018, we discussed again high temperature materials, and this was now a reciprocal meeting in Changwon. The 2017 was in Bangalore. The third event we had was again a similar theme, but with some further advances in terms of aerospace, power generation, defense industry, and that was held in Hyderabad in India. The fourth reciprocal, obviously because of the COVID, had to happen virtually, and thereafter we have adopted a virtual model of doing these kind of meeting, and this was again on aerospace engineering and materials. The fifth event, that was in 2022, dealt with advanced materials for sustainable development, and this was held in India from Kolkata, and of course, it was on a hybrid mode. As I said, post COVID, we turned to doing it on a hybrid mode, and we found that it becomes extremely convenient for our fellowship at large, both Korean Academy and Indian Academy, to join from our own workplaces and be able to contribute to taking this relationship forward. 2013 workshop was specifically on the space development, and we know that South Korea and India both have an extremely large space programs. And I was myself in Korea just about 2 months back for the global conference on space. And we have seen that what our two nations are doing is quite complementary, and there are many, many areas we actually can work together. And this is essentially when we can take our existing initiatives much ahead in terms of what we want to do in times to come. The last year's event was on current status and cooperation plan for satellites. Now, I must say, while launch vehicles, India has done much more. On the satellites, we see Korean partners seem to have done much, much more than what India has done. And this is essentially drawing on the strength of the electronics and the technology, semiconductors. And this is essentially where, as I noticed, we have a lot to do together. This year, as our earlier speaker has mentioned, it's all about semiconductors, AI, smart future. And when we talk of this, these are not just buzzwords. Today, these have become cornerstones of building future economies. And this is essentially when we see the advancements in each of our countries. And when I talk of those advancements, my mind goes to the recent Asia's the Smart Factory Automation Expo, which happened sometime in March in South Korea, the AW 2025. And this is essentially when you see an astonishing levels of advancements in smart factory automation, big data, AI, robotics. And when we see that, we realize that there's much more we can do together, and we obviously need to take that forward. I was to draw, but then again, the same region, the Taipei International Machine Tool Show, if we look at in terms of what is happening in this region, the manufacturing focus in Korea as well as in India has made sure that this year's show, India was the largest buyer at the this Taipei International Show, and this shows that our economies, when we can do things together, not only for each other but mutually and jointly, starts making enormous amount of difference going forward. The two technical sessions we are going to be hearing today and tomorrow will deliberate four panelists each of our academies and our fellowship. And this is essentially where I wish to uh, wish a extremely great success to these fruitful deliberations and the meaningful outcomes that we expect to see out of this event. Thank you very much. Once again, let me congratulate Professor Yoon for this leadership, and Jai Hind.
Thank you, President Patil. In the welcoming speech, the leaders of the two countries suggested much deeper studies and collaborations, not just AI technologies for smart manufacturing and semiconductor, but more like global issues together. Before we start the session, I'd like to let you know that we have a Q&A session after two speakers' presentation. But since the time is limited, please leave the questions in the chat, then I will take some of them. And I also request that while making the presentations, the presenter may kindly turn the camera on so that the audience can see you, and mute the microphone when you are not speaking. Okay, the first agenda is smart manufacturing using AI. Our first speaker is Mr. Won-jae Hwang, Vice President and leader of Manufacturing GX Solution Division at LG Electronics. He will present on reinvent LG Smart Factory through AX. Please welcome Vice President Hwang to the stage.
Hello, everyone. My name is Won-jae Hwang. I'm the Vice President at the PRI of LG Electronics. PRI stands for Production Engineering Research Institute. Anyway, today I would like to take about 30 minutes to introduce LG Smart Factory Reinvent, our strategies and case studies through the manufacturing AX. AX stands for AI transformation. Thank you for the time to attend this session, and I sincerely hope that it will be a valuable and informative experience for you. Sorry. All right. Today's presentation will be structured into four main parts. First, I will provide an overview of LG current smart factory initiatives and explain why a new strategy approach to reinvent was necessary to advance these efforts. Next, I will share specific case studies that illustrate how this strategy has been implemented in practice, real world. And finally, I will conclude with a brief wrap-up of today's presentation. Do you know who the person is in front of you? This is Angela Merkel, the former Chancellor of Germany. The scene you are seeing now is from the 211 Hanover Messe, where she announced the Industry 4.0. Although the term the smart factory was not entirely new, as you know well, the smart factory initiative gained significant momentum following the declaration of Industry 4.0 at the 211 Hanover Messe. But however, even after 14 years, many companies have yet to fully transition to smart factories. Against this backdrop, LG has been actively advancing smart factory development, and I will now take you through our journey and current progress. The image you can see now presents LG's overall vision for the smart factory. Actually, we are deploying the smart factories across the entire production value chain. I mean, from the product development and automation and to production system management, logistics, environmental safety, and even our partner companies. Moreover, in driving smart factory initiatives, we aim not just to create the smart factory for the sake of being smart, but the smart factory that truly contributes to the tangible business performance. Now let me introduce a representative case of the LG Smart Factory initiatives. First, let us look at the Changwon refrigerator factory here, which was designated as a lighthouse factory by the World Economic Forum in 2022. This factory achieved over a 20% increase in productivity through the implementation of the intelligent autonomous operation system. And 2023 here, our North American washing machine factory was recognized as the first overseas lighthouse factory among Korean companies. And this facility is equipped with a fully integrated manufacturing system capable of handling everything from the component production to final product assembly. And our Cheongju cosmetics factory is pursuing full automation with the ambiguous goal of quadrupling productivity per employee compared to previous levels. And lastly, our battery plants in North America and Poland are strategically located near customers, enabling production and supply chain stabilization. Through its tailored strategies adapt to unique characteristics of each industry and region, LG continues to strengthen its global manufacturing competitiveness. What you see now here is the Changwon refrigerator factory in Korea, which I mentioned earlier. I mean, the lighthouse factory. The video on the left shows the refrigerator assembly line as it operated in the past, where welding, inspection, assembly, and other processes were performed mostly by workers. But in contrast, the video on the right depicts the current factory where the integrates and intelligent production environments has been established based on advanced technologies. Robots and automation technologies play a key role in maximizing the efficiency of repetitive tasks and reducing the burden on workers. Additionally, AI technology has been integrated to analyze data in real time and implement a predictive maintenance system that detects quality anomalies in advance. Through the digital twin technology, physical process can be simulated in virtual environment, allowing optimal operating conditions to be verified ahead of time. These diverse technologies are interconnected, enabling LG Smart Factory to evolve into an increasingly intelligent and autonomous operations. Right. Now I'd like to explain the backgrounds behind the LG's decision to pursue the reinvent the smart factory, a kind of new approach to smart manufacturing innovation. To begin with, the smart factory market is projected to expand really rapidly, as you know well, and in particular, strong demand is anticipated in LG's core business area too, like electronics and healthcare and automotives electronics. While the market is indeed growing, the business environment is more uncertain than ever before. You know, global economic instability, geopolitical tensions, and supply chain disruptions are increasing the overall complexity of the manufacturing operations. In this context, the smart factory is no longer merely a means of improving production efficiency. I mean, now it is being recognized as both critical survival strategy for navigating periods of uncertainty and foundation for future growth. And moreover, recent advancements in AX technologies, including, as you know well, AI and XR and robotics and 3D printings and so on, they are enabling new implementations that go beyond traditional smart factories. Amid this wave of change, LG is committed to building a truly intelligent smart factory through its new innovation framework, Reinvent. I would like to explain LG's smart factory strategy from 4 key initiatives. First one here is the perspective of equipment investment costs. Previously, investment decision focused mainly on minimizing the initial costs, but this approach led to either equipment caused by discontinued production models and the development of new models in response to changing market conditions. To overcome this, the investment decision must consider equipment reusability with focus on optimizing total costs. And second one is the perspective of operator skill levels. As automation increases in existing lines, the complexity of the line operations also rose, creating a demand for high-skilled operators. So as a result, the efficiency of the production lines began to be affected by operator proficiency. So LG has implemented no-touch operations to minimize operator interventions in equipment and teleoperations to enable non-skilled workers to be remotely guided by skilled operators. And third, the recognizing the limits of the improving productivity solely through the maximizing equipment capacity and the minimizing loss. So LG is pursuing process innovation, exemplified by Tesla's Gigafactory. And finally, while we big data analytics are based on legacy IT system that help to analyze production loss causes, but their ability to enable immediate on-site response has been limited. To address this, LG's aim to implement a comprehensive manufacturing AX system that covers everything from issue root causes analysis to real-time on-site response through the manufacturing AX. There are many reasons why achieving a truly smart factory remains actually challenging. According to Gartner, the most common obstacles faced by companies are the high cost burden and technological limitations and the difficulties in scaling across multiple sites, as you can see here. To address, and the World Economic Forum has also highlighted this issue, referring to it as a scaling slump, a phenomenon where the initial excitement of adopting new technologies phase and implementation progress stalls. To address these challenges, LG has adopted a platform-based approach. And this platform is not merely a tool, but rather strategic foundations that allows innovation technologies to be rapidly and easily and cost-effectively deployed across production sites. As illustrated in the image on the right, if data, the raw ingredients and the AX technologies are the kitchen tools, and then the platform serves as a pre-packaged meal here that seamlessly bring these elements together. The final dish can be customized to meet the unique needs of each factory and its operational context, such as LG is achieving both scalability and flexibility through its platform-driven smart factory innovations. From this point onward, I would like to share some how LG is addressing the real-world challenges in its journey to realize reinvent LG Smart Factory vision. And LG approaches smart factory innovation through 5 key focus areas, from this product development to inspection process system and shop floor AX and physical AI, and detailed technology cases in each area will be presented from now. Let me begin with the example from the product development domain, specifically focusing on PCB design automation. On the screen, you can see 2 PCB layouts design, one created by skilled human engineer and the other automatically generated by AI. Can you tell which one was designed by engineer and which one was by AI? The answer is the left design was created by engineer, and the right design was generated by AI. However, this AI-generated layout was not achieved overnight. It's the result of the numerous development iterations and repeated trials and errors over the time. At the center of the screen, you can see the PCB layout by earlier version of AI model. To reach the current level here, we had to develop advanced modeling capabilities that could simultaneously satisfy numerous design constraints, such as wire lengths and the component spacing and the placement rules. And moreover, to shorten the AI model training time, we reduced the complexity of the model architecture and leveraged by GPU-based distributed learning. Another critical challenge in product development stage is the prediction of the quality and performance. Traditionally, as shown here, the process required building numerous physical mockups and conducting tests that spanned several weeks to months. You can see the numbers beside the pictures. These tests are typically relied on collecting data manually and documenting quality results offline, and making data reuse difficult, and resulting in limitations in both speed and efficiency. To address these limitations, LG has been advancing on initiatives called the Virtual Performance Development, VPD, a method that enables performance prediction without the need of physical testing. Transition to virtual product development at LG is being driven by four key directions. First is a simulation-based approach. This enables accurate prediction of various factors, such as drop impacts for TVs and internal temperature distribution in refrigerators, and vibration and noise in washing machines, and crush safety of the automotive parts without any physical prototypes. And second, AI-based performance prediction. Here, for example, we leveraged over two ensemble models to optimize control parameters and apply deep learning models to CAD data to predict quality outcomes in injection molding process. And third, web automation. The entire testing workflow, from the remote testing and sensor-based data extraction to automated result storage, has been fully automated. And finally, here, we utilize generative AI to search and classify hundreds of thousands of development documents, enabling engineers to quickly access and specific information they need. Now, I would like to share some example of inspection AI. Traditional vision inspection has relied primarily on optical equipment to capture the surface appearances or patterns, with human operators manually reviewing images and to determine the defects. This approach has several limitations. The accuracy varies significantly depending on the operator's level of experience and conditions, and the repetitive nature of the task leads to high level of fatigue. Now LG is taking a fundamentally different approaches in this area by implementing AI vision inspection technology. First, the AI system performs image augmentation to generate synthetic training data and visually defines the defect criteria to enable automated decision making. Additionally, we built an ops platform, MLOps platform, allowing even non-experts to train AI models and deploy them to field without any coding. And now I would like to introduce next generation technologies that are currently being developed and implemented. First thing is the automated labeling. With the single click, the system can automatically detect and label the similar objects, significantly reducing the manual efforts. And second one is a small data learning. Instead of requiring massive data sets, we now leverage pre-trained models specialized in vision inspection, enabling the development of high-performing AI models using only a small amount of data. Now I would like to share an innovation case from the production system domain, specifically related to factory operation simulation using digital twin technology. In the past, when we building a new factory, verifying layouts and logistic flows required experts to write the complex code, and the single simulation could take more than like 3 months to complete. Moreover, the scope of validation was typically limited to logistics design and making it difficult to simulate and evaluate the entire production operation in a comprehensive manner. To address this, LG has developed a simulation-based design verification that is easy for non-experts to use. The key feature of this platform is modularization of the 4M elements. I mean, 4M means a man, machine, material, and method into reusable libraries. Users can easily create the models using a drag and drop interface. And this platform has dramatically improved the speed and scope of design verification and provides a foundation for anyone could easily perform the pre-operational simulation. The pre-verification simulation platform I just described is now being extended to enable the real-time optimization through the factory operations. For example, by connecting simulation models with existing systems such as manufacturing execution system and material control system, we can visualize real-time logistic flows and work-in process status and supply conditions. This enables proactive issue prediction and response within minutes, moving beyond the simple design validation to deliver tangible improvements in operational efficiencies and minimization of the production losses. Next, I would like to introduce a case of AI agent application in the area of material management. Previously, material shortage or related issues had to be mutually checked by the person who would then email the relevant department to take action. But now it's a, sorry, I should change the PowerPoint to the click. Now, however, AI agents automatically detects and reports material issues each morning. If not only present a list of issues, but also suggests potential solutions. When needed, the agent can automatically draft mails such as urgent custom clearance requests or alternative material substitution requests for non-bill of material parts and facilitating communication with the relevant teams. In addition, we can predict the impacts of the material changes on production plans and update the production system accordingly through the system integration. As a result, LG is to reduce the time spent on repetitive checks and documentation, while the enabling faster and more effective response to the optimized decision-making supports. Next, I would like to introduce case of logistic automation. LG Smart Factory has established a fully integrated logistics system based on AMR, automated mobile robots, and and for example, the mobile robots autonomously transport mount and retrieve large and heavy and expensive electrode rolls without human intervention. And they are not only handle product transportation, but also automatically manage product inputs and outputs with the production process. Additionally, instead of relying on a separate lift system for interfloor movements, robot now directly use elevators and demonstrating innovative advancements in logistic operations. AMR-based logistics automation introduced earlier represents more than just mobile robots. It's an intelligent logistics operation system. Leveraging SLAM-based autonomous navigation, the system dynamically adjusts routes in real time, responds to environmental challenges. At the same time, a route optimization system enables centralized control of the multiple AMRs according the overall logistic flow to maximize operational efficiency. AMR based logistic automation can also bring some significantly improvement in the handling of abnormal situations. In the past, when a failure occurred, operators had to physically detach the two sites to perform manual location correction and recovery operation. But now, however, raise point here. Now, however, thanks to remote operating system, it is possible to respond anomalies in real time from remote location, including the route adjustment and the return to base commands. As a result, response times has been drastically reduced, and the continuity and the stability of logistics operation has been enhanced. And to advance manufacturing site, LG has established the shop floor AI transformation strategy. And this strategy is structured uh, around a series of progressive stages. I mean, the digitalization and the intelligent automation, teleoperation, ultimately unmanned operation. For each stages, LG has developed detailed sub-strategies covering areas such as training and the operation management and on-site response, I mean, the action. Uh, Now I will explore specific solutions that correspond to each of these strategic domains. First, let me introduce a case involving the application of virtual training simulator for operator training. Traditionally, training was conducted by paper manuals, which required considerable amount of time to workers to reach productivity. And now it's the introduction of virtual simulators. Operator can learn equipment handling procedures and worker flows in simulated environments. A similar case involves the shift from paper-based manuals to 3D guided instructions for handling abnormal situations. Now with the 3D based guidance, they are intuitively directed where and how to take actions when alarm occurs. And next is low-cost equipment data collection. Today, LG utilizes low-cost embedded hardware to wirelessly collect both digital and analog data and integrates lightweight AI models to enable smart sensor functionally. As a result, real-time equipment data can now be gathered and more efficiently. And this is a case of equipment failure prediction and process quality anomaly detection. And installing sensors on all these points would be costly and challenging to manage. Therefore, LG collects data using PLC without any additional hardware for data acquisition and applies an algorithm based on PLC data to predict failures. But in some cases, depending on the criticality of equipments and the severity of the potential failures, faster and more accurate fault detection based on sensor data is required. So we apply low-cost hardware developed in-house along with the lightweight AI models that can learn on this hardware. And this is a case of real-time anomaly detection system using video AI. This method was subject to variation in quality depending operator attention. There was risk of missed anomalies or delayed response. Now, so with adoption of AI-based real-time video analytics, LGS established a system that automatically analyzes video streams and triggers immediate alerts when anomalies are detected. Next, I would like to introduce automated response system that is integrated with the real-time anomaly detection. Once anomaly is detected by the AI-based system, it automatically links to the PLC or any controller system, enabling intermediate actions such as equipment shutdown or alarm activation. Next, I will discuss guardians of design to enable operators to respond immediately to a normal situation on site. Various solutions are being explored to improve response effectiveness. These include digital manual access via tablets and the AR action guide and generated AI tools for retrieving historical response records. Next is remote and automated response system for normal systems. On the video left on the screen, you can see the case of remote expert assistance. I mean, when operator encounters an issue, remote expert can connect the real-time view the operators on site screen, providing step-by-step guidance for resolving issues. On the right side, you can see the automated control system using the AI models to control the temperature and pressure of the injection molding. And here is the last shop floor level of the AX. I would like to introduce the end-to-end operation platform. I think this is the most important thing I want to tell you as a case studies. On the video on the left on the screen, you can see the equipment anomaly response interface. When an issue arises, a real-time mobile alert is triggered, providing both location of problems and the corresponding action guide, which enabling operators to respond swiftly and effectively. So operator can input response actions verbally and system automatically generates a summary reports for documentation and review. And on the right side, you can see the quality anomaly response process. Here, the defect types are automatically classified by AI based on AI, and guidelines for each types are provided instantly. This helps reduce cognitive burden on operators and enable consistent and standardized quality response. And this is another examples for line factory automation. On the left side, we are calling the Vision MES. Using the Vision AI, we replace existing MES with the business system. On the right side, we are using the AI CCTV. We detect every issues on the manufacturing field for safety and environment issues. And this is the last case for this case studies. Nowadays, we are really focused on the physical AI things. We are using a lot of AI system, I mean the vision AI and the sensor AI, and here at the effector, we also use a lot of general purpose and flexible gripper and the gripping anomaly detection with the sensors and dual arm humanoid with the base the AMR. All the hardwares are combined to connect to conduct the physical AI, which are really hard with the traditional automation solutions. Here is examples for our tries for physical AI. The first thing is the cases for using the robots detection. I mean the fastening the screws. As you can see, with the just robot, it's really hard to do the same actions exactly like the operators because the operator using all the senses they can have. So now to do that, we used a lot of simulations and the vision AI and a lot of software systems to support this fastening operations. And the second one is bin picking solutions. We also use the AI solutions because fixed status, a lot of things cannot be done robot by themselves. So we are using a lot of AI solutions. Even the position of the materials are not fixed. There is another cases for AI. We with the inspection with robots. Traditionally, a lot of people are doing their inspection by their eyes, but now we are using a lot of AI system and robots. It's automatically done by the robots. And that this is assembly line with the parts on the pallets. We are using a lot of AI system also to assemble these operate automatically. Okay, it's a long time journey. It's final wrap up. As you know, India and LG has already established a long and inseparable partnership, as you can see here. We hope the cooperation between India and LG Electronics will continue and deepen and fostering a mutual beneficial and sustainable with the win-win relationship in the future. LG Production Engineering Research Institute, I mean the LG PRI, is well positioned to play a vital role and crucial role in the expanding cooperation between India and LG. And the LG PRI is smart factory business to be the game manufacturing changer, as mentioned here. Beyond being simple solution provider, LG aspires to lead the manufacturing innovation. To achieve this vision, LG has developed integrated smart factory capabilities covering entire life cycle from the manufacturing planning and strategy levels to the solutions for factory operation and so on. So building on this foundation, LG is advancing toward securing global manufacturing leadership. With these smart factory capabilities, we hope LG PRI will be also instrumental in strengthening the partnership between India and LG. And this is the page I presented for today, lastly. And thank you for your attention. And any question will be welcome. Thank you.
Thank you very much for your insightful speech and sharing with us the great vision of LG Electronics smart manufacturing. Now, we welcome Professor Janekrajan Ramkumar, Professor of the Indian Institute of Technology, Kanpur. His presentation is titled AI-Driven Smart Manufacturing Logistics. Please welcome Professor Ramkumar with big applause.
Is my screen visible?
Yes, you can see.
Yeah, so have I gone to the first slide? Is it visible? Can I go ahead?
Yes, you can start.
Yeah. Thank you so much. Thank you so much to the host. Thank you so much to INAE as well as NAEK for giving me an opportunity. And it was a well-placed lecture next to LG, because LG is one organization where they have introduced so many AI-related products and algorithms. So my talk will also be in that line, but I will try to talk about some of the algorithms which we have developed at our lab at the back end for a smart factory. So this work is jointly done along with Rahul Segal, who is a research scholar, and Segwal, and then along with Professor S.N. Singh, who is currently the director of IIIT Gwalior. I'm not able to move to the next slide. I have to stop. Is my screen moving? Yeah. Okay. So the overview of my talk is going to be a small brief introduction. And then I will try to keep more focused towards smart manufacturing. And here in smart manufacturing, I am more focused towards using non-renewable energy. Sorry, using renewable energy for a smart factory to application. Then I will move to electric automated guided vehicles, which also follows a similar one of electric vehicles. Then I have 2 case studies to be discussed. And finally, I will try to link AGVs and EVs for keeping one particular agenda of charge optimization. And finally, a conclusion. When we talk about smart factories, it has been a concept of using technology to coordinate physical as well as digital processes within the factory across the manufacturing supply chain. So when we are talking about industry 5.0, so wherein which there is lot amount of data which is generated from physical, this data has to be processed, and in this data you will have multiple variables, and each of these data will be recorded in different units, plus it has to be processed. So in smart factory, we try to integrate advanced technologies such as IoT, AI, robotics, and data analytics to optimize production process, enhance flexibility, and improve efficiency. When we talk about enhanced flexibility, today we are talking about the concept of B2C, or more and more mass customization. When we look at products FMCGs, or when we try to look at discrete part manufacturing, wherein which it is more focused towards residential or house, what my previous speaker was presenting. So there in which you will see there is more and more requirement for mass customization. So understanding the data and then giving it to the customer. So it enhances automation, real-time monitoring, and data-driven decision making. When we generate data, today the beauty is we generate so much of data. Why? Because we have so much of sensors available, and sensors are also getting tweaked and tweaked to have multi-sensor fusion. Earlier it was one sensor measurement, now it is multi-sensor measuring multiple data and then accumulating it. There are a lot of data available which is relevant for supply chain and the factory automation. Then this data has to be contextualized. The information is combined with the combined to have a really more deeper insight. So once you make the available data contextualized, then what happens? You try to understand more relevancy of that data. Now this data is now taken to the next step of data activation, wherein which we are trying to use today AI ML in a very big way to take decisions. And finally, based on the decisions, whatever we take, we are trying to take actions. So these are the 4 things which we are trying to look forward: data availability, data contextualization, data activation, and data actions. A smart factory, smart manufacturing will encapsulate smart factory. So when we try to look at smart manufacturing, these are all the important things which are getting used today. Digital twin is one thing which is very much talked today, and using of AR, VR for training people to understand people. When we move from smart manufacturing to smart factory, these are the big time contributors for this. Blockchain and big data analysis or analytics is something which is very important which is more talked about in a smart factory. So in a smart factory, what we talk about is, we talk about cobots, which is collaborative robots, and then we talk about AGVs. My focus will be more towards AGVs, because AGVs are used for loading, unloading items in a lot size or in a ASRS system. From there, it is loading, unloading to meet out to the customer requirements. The customer can be a machine requirement. The customer can be a truck which takes the goods and keeps moving. So AGVs are very, very important today, and my focus will be more towards AGVs, then digital twin, big data, virtual reality, and sensors. So these are the 6 major contributors towards smart factory. So here I have case studies. There are 4 case studies which I am looking forward. So here I have all these case studies are attached with AI driven, so that we can try to do optimization in terms of electricity charging, electricity forecasting. So the AGVs have to be charged. How are we going to charge these AGVs? What are the backend algorithms we can use in this area? So case study, I have taken AI-driven electricity pricing forecasting and EV AGV charging optimization. I have taken four things. One is price volatility can significantly impact charging decision on large EVs and AGVs. For example, today we talk about a warehouse where there are AGVs of almost thousands of them. So when we have thousands of AGVs there who are supposed to do the work, so now the important thing comes is their battery. So now charging becomes very important. Now across the world, the concept of dynamic charging is getting more and more talked about. So the first thing will be price volatility can significantly impact the charging decision. Second thing is data-driven deep learning forecasting algorithms for short-term pricing forecasting. So this is one thing which we have considered. And the third thing is battery conscious task allocation and charging. When are we supposed to ask the AGV to go for a charging? Should we keep it 20%, 25%, 30%? Or should we say the shortest path we'll try to do and then it will come for charging? So that's the third thing. And the fourth thing is formulation of mixed integer linear programming problems will be talked about. When I am looking forward at the process flow, first what I am trying to do is, you still keep in mind the 4 steps which I talked about: data acquiring, data contextualization, data analysis, and based on the data analysis, decision. So here is a flow chart which I have used in my presentation. So here I will compare analysis of ML algorithms for price prediction, because when we are trying to talk about smart factories, the costing is also one. So the costing by default goes on the electricity consumption also. So here, first I will try to compare analysis of ML algorithms for price predictions. Then I have developed RNN and LSTM algorithms, which will best suit for time series forecasting has been done. From there, I have tried to move to enhance SLSTM algorithm employed for make predictions. And then I have done future selection and attention mechanism. From there, I have integrated this algorithm to EV. Then I have done trans-learning based forecasting of EV integrated systems. Then finally, EV charge optimization and EV charging ecosystem and policy recommendation. So here I have used the ML algorithm is bidirectional long short-term memory, which is BI/SLSTM. Okay, this LSTM stands for long short-term memory. So when we try to look at one LSTM, this is what is the schematic representation, what happens at LSTM. So you will have an input which is given, then there is a forget gate. This forget gate will normalize and try to remove all the noise data, and then it will try to push in the relevant data into input gate. From the input gate, it moves towards the candidate for cell state update. and from there it will try to go towards the output. Based on the output, the decisions will be taken. So you will have an input which has a forward layer, which has a backward layer LSTM. Then from here it moves towards activation layer. You can see from forward directly it can go to activation layer. From backward also it can go to activation layer. And finally you see an output. So this schematic diagram represents the ML algorithm for bidirectional long short-term memory by LSTM. So, and then I have also used CNN model where there are input layers. Then you will have convolution layer, pooling layer. From there, that leads to flatten layer. From there, dense layer, and then you have an output. So this is an algorithm for CNN, and this is an algorithm by LSTM. So what are the data I have taken? So the data predominantly I have taken is the pricing. So pricing for the load I have done from 4 different regions in Sweden grid, where I could get this data from the literature. So I have taken the actual load pattern of 4 regions of Sweden grid. Now with this data, I try to calculate the mean, which is towards your right hand side. So there I have calculated the mean price variation hourly and also monthly for 1 year. Then I have also calculated the mean load. First was price, from the bottom I went load. Today when we talk about dynamic pricing, depending upon the load, the price goes higher or lower. And though it might look little off the track when we keep the production into account, but all these things keep adding towards the cost. So today we wanted to give mass customized product at a lowest price as much as possible. So that's why we try to look at the load and the cost, what happens. And this is for a load which is given in the Sweden grid. Okay, so the left hand side bottom, what we present here is the electricity pricing for 1 full year. So here what I have done is I have divided the data into maybe 50%, then 30% and 20%. So you can try to vary the requirements. So here 70% is used for training data, 20% is used for validating the data, and the last 10% I have used it for testing the data so that I can tell my algorithm is working or not. So on running the LSTM price forecasting, you can see here what is the difference between the actual price and the forecast. So you can see here it is very close by, but still when we talk about financial, it has to be more close and the error should be as minimum as possible. So first we tried the LSTM algorithm. So we got the price forecasting. Then we tried to do by LSTM. So this was done, and then we saw the variation between actual and forecasting. So here we could see the pricing using CNN model, and then we could also run to stacked LSTM price forecasting. In the next slide, I will discuss about the stacked LSTM price forecasting, here in which I have represented the error. So you can see here what is the LSTM error, RS root mean square error, then MAE error, then R square fitting whatever is there, then training time, and then each stop after every epoch, what is happening after 35, 47. See, the algorithm is so very well developed. So you can see in very short time, we are able to get the good results. And then if you see, we are able to get through CNN in the training time is 36 seconds. We are able to get the data. So this is what I was trying to discuss about in the previous slide, stacked LSTM. I present it here. The variation in the algorithm of the stacked LSTM is going to be like it is vertically stacked. You have LSTM1, then leading to LSTM2, then that gets attached to an activation layer. From there, it goes to fully connected dense layer. So here, through this algorithm, we are trying to predict the data. Now, friends, when we closely watch the annual data which is got in last 1 year, we could find out there is a lot of discrete data, or there are a lot of missing data. So the blue one are the data which is acquired for last 1 year from 4 grids, and then the red one talks about the mean. So when we closely watch it, you see that there is a lot of discontinuity in the data. So we are now trying to look at all the discontinuity in the data, try to understand and try using this SLSTM algorithm to merge it and get the original data or the accurate data. When we did so, we first ran the autocorrelation. We got this autocorrelation was done, partial autocorrelation was done. We could get the data fixed. So through this box plot, whatever we show here, we see a lot of black dots, which these black dots are the outlier points. We found out what are all the error outlier points or missing data. And then what we could do is we could do the correction and finally get the electrical load box plot without any error. So now with this too, we did two things. One is price forecasting we did, and then we did hourly price forecasting. So when we did price forecasting, it was for time. We could see here. So this is all reported in euro. So we could do that. So this is the actual, blue is the actual, and red is the forecast. So what does it mean is, now I can forecast the costing. So now based upon the forecasting forecasting, I can try to ask the AGVs, whichever is there, go for charging or don't go for charging, or hold on till the time is over and then go for charging. When you are still there, you are supposed to do job. Based upon the battery power available, can it do one more round of iteration? So all these things can be now understood from this forecasting prediction. So from there, we could move to a feature selection. So here, in which earlier it was only two data we did. What was it? One was price, the another was the load. But when we try to talk about these using of renewable energy, there are multiple things which are involved. For example, we are trying to use solar. When we try to use solar, it's the temperature, relative humidity, all these things come into existence. So here, in which I have plotted all the different variables with respect to load. So now I put everything into a feature. From this feature, I try to select based upon whatever I want to make sure the load and the pricing. I am not even interested in the load. I am only interested in the pricing. So I did this feature prediction and I saw how close is my stacked LSTM price forecasting with respect to actual. So from this, I could see the root mean square error is been reduced by 25.74%. MAE is reduced by 28%. The R square has got improved by 22%. Also, the training time got improved. So that means to say I have more amount of data, and all these data live, I am trying to run my program and extract it. So when I try to extract it, the response has to be as quick as possible. So that's what is presented here in this RSME reduction used upon the feature selection and attention enhancement. I can pick whatever feature I want and that particular time, and then I can do. So here you can see the how was the data processed. Then the Pearson correlation matrix was used. From there, I did a feature selection. The feature selection again I ran through the SLSTM. You remember previously I said SLSTM ran for 2, found out the best one. So then I have drawn the schematic, how is the program running to get the required output. Now from here, what we are trying to do is, existing data is there. So for the existing data, I can do whatever is the algorithm prediction. Now, what if I don't have an data, but I have to do some amount of prediction based upon the model which I have run. So here what I am trying to do is, based upon the data available, I am allowing the system to transfer learning based on the framework whatever I have, so that I can try to do the prediction for the data which is not available. So here using this, I am trying to tackle the issues of lack of data, especially the EV charging, whichever we don't have, then generalized data across different systems. So this can be tackled through this transfer learning method. So it is accurate, it is very fast. Here it does non-linear learning, and the temporal complexity of raw data can be handled. So here I have developed this algorithm, And in this algorithm, what I have done is, through this transfer learning, I have fixed the frozen two layers where the weights are fixed. And in the blue, I have kept on changing the weights. So by doing so, I am able to predict the electricity price. So these are the plots, and I could get 10% better reduction in the data for the position or the slot where I don't have data. So from there, I try to move towards EV charging optimization based upon the tariff variation within the day. What is the cost? Then irradiation and PV variation. Friends, I was trying to talk about multiple inputs given. So I said renewable energy. Solar is used for giving power to the factory. So what happens? Various irradiation and PV variation. What is the temperature? What is the irradiation? I could do all the forecasting and try to get the actual data. So this I have plotted with respect to power and hour. So what is the optimal charging for EV we have to use such that I can make best use of it. So now, friends, we have studied for an EV. Now let me get into the mapping or algorithmic thinking process of mapping the EV with AGV. AGVs are used exhaustively in a smart factory. So it is used for handling requests for the machine, and also it is used for supply products, search for trade-offs and charges. So it has battery operating stations also in the schedule. So now what I'm trying to do is I'm trying to go to a real time, pull out the data, what will be the battery charging, where are the machines allocated inside a factory, how do I do it? So manufacturing 4.0 operation schedules with AGV battery management constraint also, right? We are trying to save energy, save time and save money. So this is a real time, we have taken data from the literature. These are the orders placed. These are the operations, transportation operation. These are the loading points, unloading points. What are the density to be handled? Because the AGV cannot handle infinite load. So that also is a constraint. And what is the processing time? And also you have to maintain the processing sequence. First, then second. So you have to also maintain the precedence diagram for loading or unloading. Okay. So these are the containers task, and this is the time. So here in which I have represented whatever is there in the table in a pictorial form. So now we are trying to first see AGVs which are going through inside the factories. You can have traditional parallel layouts, traditional vertical layouts, and then you can try to also have fishbone layouts, right? So parallel layouts, vertical layouts, horizontal layouts. These are parallel, these are horizontal, these are vertical, and then you can also have fishbone layout. Why are these layouts coming into existence? Because the time with which AGV goes, how quickly it can go access the entire factory or the machines. So here I have put the shelves, I have put the channels, and then I have said AGVs when it will move. So now all the AGVs are there. Whatever I have done, the EV, ML, AL, whatever it is, I have stuffed into the central unit here. So there, apart from scheduling, routing, dispatching, I also will have the AI/ML, which will try to talk about the cost of the pricing here. So typically, if you do a computer simulation, these are all the AGVs. These are all the points where you will have all these things, right? So this is a scenario we have. So we use camera. So OpenCV is used. Then artificial intelligence algorithms are used. AGV routings are there. This is independent of my AI for costing. Then motor control will also be done. So now I have tried to take optimization problem. So MILP optimization problem I have taken. So here in which I have put the constraints like battery constraints, task assignment, task precedence. These are all the constraints, and decision variables I have chosen, and then charging constraints I have put, and then EV, AGV energy consumption pattern also I have put. Now using all these things, these are all the constraints with respect to battery and electricity charging. But now there are also other constraints in a real time. Pollution should be avoided. AGVs can carry only one piece at a time. All these things are other assumptions or constraints I have added to the problem to make it more and more realistic. So based on this is the scenario. This is the layout we have taken. And there are dual scenarios I have considered. So the first scenario is going to be deals with pre-empty energy estimate, where task allocation amongst various AGVs is done only if the battery charging level of the AGV is sufficient to complete that task. That was the scenario 1 I assumed. Then I assumed a scenario 2 that it should have minimum 20% of the battery charge so that it can try to do the task. So two scenarios were taken into consideration. Now I ran the algorithm to get scenario 1, scenario 2, scenario A, scenario B. So now in this scenario A, you can see actual working is happening here, and the orange or the yellow, whatever is there, is the waiting mode. So the AGVs are not effectively utilized. Friends, keep the charging cost also into consideration. When I go to scenario 2, you can see here green are where the AGVs are working, blue are where the charging modes are coming into this thing, red are task resumption left incomplete because the 20% was target was hit. So based on this, we could do optimization. We could run scenario A, scenario B, and then we could reiterate the process. Finally, we compared the benefit. So this is a comparison chart. More ideal and waiting time was observed in scenario A as compared to B. So if you are trying to look at only optimizing the AGV utilization time, so you will see B is good. But B provides incremental of operational cost due to lack of resumption activities and 20% increment in total energy consumption. So now you have to hit a trade-off between A and B. Algorithm B provides more productivity, optimization scheduled results for dispatching of EGVs. So EV AGVs is done here. So now this is only one case study I have run and we have developed it. So to conclude, the smart manufacturing facility employs a huge number of AGVs, and we have to make this more and more realistic, wherein which AI and ML algorithms will give you a better perception and will try to give you the best result options. Large number of workstations ordered further complicates the situation. The research work provides only a new solution for EV AGVs, but in real time, you have to take many more variables. The battery SOA conscious approach has been employed for optimization of the task. The proposed method has been found to make more energy efficient and cost optimum solutions. So the further directions is going to be, we have, for instance, loading, unloading time, collision, blockage can be taken more realistic and find out the shortest path optimization can be run. So the next thing is, for generalizability, it can be tested on diverse smart factories. We have taken only a warehouse of Amazon, but you can try to do it with multiple things and develop a more realistic model. And finally, the advanced optimization solutions like reinforced learning can also be adopted to make the AI ML more authentic. So this is a small group with which I have been working so long. Thank you so much.
Thank you very much, Professor Ramkumar. We could heard that AI is already actively applied smart manufacturing. There is no question, and we are out of time, so we will conclude this part. Thank you again to Vice President Huang and Professor Ramkumar for your excellent presentations and detailed information on smart manufacturing using AI. Okay.
Thank you so much.
Thank you.
Thank you.
Yeah.
Thank you. Thank you so much.
Thank you. Okay, so now we are moving to part 2, international opportunities in the AI sector. Our next speaker is Dr. Jae-sik Choi, CEO of Inage Company, and also a professor at the Kim Jae-chul Graduate School of AI at KAIST. His talk is titled AI Transformation of Manufacturing Processes in Korea. Welcome, Dr. Choi.
Hi everyone. It's my great honor to present some of transformation by AI in the manufacturing process and the domain in Korea. So probably the part of AI algorithm is in the prediction algorithm, as Professor Kuma says. So there are some related part. So I will try to briefly overview the AI technology trend. So globally, so that is actually what Jensen Huang recently say. So AI is improving from the perception from the vision system and the generative AI, which is like visual generating system. And currently we are in the agentic AI system, which several agents play each other, and then also go to the physical AI. So nowadays, physical AI is a global trend, and also physical AI is one of the key part of the manufacturing AI process in Korea. So many startup company and the government try to spend investment money for the physical AI, including robot and the autonomous AI system in manufacturing. So as we can see in the LG factories. So physical AI is about small agent, but it will enact many autonomous procedure, which is diversified manufacturing. So that is actually one of the directions that we can predict. So this is the lighthouse factory, like a history from the World Economic Forum. So World Economic Forum says, so they observe a lot of factory over the world. Recently, a lot of factory in China and India selected for the lighthouse factory, and also Korea. So 6 factories are selected, including the LG. And I also collaborate POSCO to make the first lighthouse factory in Korea in 2019, and they are selected. So the common observation is, so we are gathering the data from the manufacturing process and try to learning something, and try to apply these new things in the algorithm. So that is say the doing, and not all of those doing are successful, but some of them are successful to optimize the process itself. So when we optimize the process, as you can see, we can save the energy, or we can make the more production, and we can make more efficient production where we may have a better quality. So nowadays, the better quality product for the high demand, high-end product is one of the key part that South Korean manufacturer concentrated on, that I will try to explain a little bit later. So we can say, so that is strategically very important, because one of the consulting firm, the PwC say, so in about 15 years, so global GDP will grow in 15%. Then the China itself, of course, actually China has a supplier and the demand at the same time, in that same period, like that Chinese economy will grow 14.5% in 15 or 20 years. And the global supplier in hardware and the software, and then the US will grow the GDP into 26%. And it predict that so the other country, something like Korea and the EU, and the growth of the GDP by the AI may be less than 10% because of lack of global services that they provide. So probably the India may be more than 10% because Indian economy is grow faster than the Korea, but GDP growth in the Korea is lower, and also AI global service is not really strong in Korea. So if it is not strong, then it is expected that the economic effect of AI in Korea is not really big. But somehow, Korea has some opportunities. So you can say that SK Hynix as a global leader, it provides HBM for the GPU. And also South Korea has a strong, the data center compound, something like transformer, electrical transformer, and the circuit breaker. And the copper wire is actually one of the big parts South Korean company provided. Of course, if we go to the GPU, then the PCB board that South Korean company provide, and also CCL, copper clad laminate, which is coated in the GPU board, is one of the South Korean company are leading. So in terms of AI hardware, so South Korea has some like a gap to provide the global service. But in some of the AI software, so South Korea tried to getting the like more visibility in this area, especially like manufacturing AI and also AI service. So that's the reason why South Korean government and the company are concentrating more about the sovereign AI to make the AI like AI know-how itself in the South Korean company and the organization and try to export to the global service. So that is very important. And if we try to getting this picture in the good, like a big hand, then we can say that the AI make many procedure, even in the manufacturing, from the like build time optimization to the runtime optimization. So if you think about autonomous car, then before we have autonomous car, the car is just after like sold the car, then the customer just run the car. But after the like autonomous car, we can analyze how driver safely operate the system or not, and so on. And also most of AI system in the manufacturing also try to optimize those processes in the runtime. Most of sensor what people do, operator do, and also other IoT devices do are like well stored, and they are well analyzed. And like alert system or abnormal behavior are like monitored and alert in the real time, and that are well processed, and sometimes autonomous procedure get it into the control procedure and the autonomous drive, those like AI factories. So that is also one of our vision and goal, and that is our South Korean like manufacturer try to do. So we can simply say that we have even if a lot of data lake and the algorithm itself, what we try to do is runtime optimization of the process system in the manufacturing the industry, as World Economic Forum say previously. So let's try to think about more about discuss about the procedure in Korea. So application of AI in industrial sector. So, like, of course, many company or country has like these kind of risk in terms of manufacturing. So, especially East Asian or Asian countries. So, rising electricity costs due to of the war of other like tariff and other scenarios, and also like one of the big important thing is a loss of tactic knowledge of the like aging situation. So we can say that so population aging is a global trend, especially East Asia, something like Japan and Korea. This population aging is at the risk, especially from the manufacturing side, because of the like population tree or like a lack of those tactic knowledge are like disappear rapidly. So it is really important to getting this knowledge before they retire and are getting old. So this type of knowledge, so because actually these countries like Japan and Korea has a small range of the like middle age or young age worker, so it is very important to getting this experience knowledge in the manufacturing to learn by AI and autonomously or standardized way to run this factory well again and again. So like a different country and a different company has a different like a situation. So I try to getting so one of the example from the Siemens. So Siemens, of course, actually Siemens has a lot of like market share in Korea, not only for the hardware, the control, but also the software. So Siemens is very strong in the hardware and the software, especially for the simulation. So what Siemens say that is, so they will try to use simulation tool to make the more realistic simulation, to make the AI data like more abundant, to make the AI like the system better. So that Siemens will use a lot of different simulation tools to make this AI data abundant, and then they will try to train the AI model better, like to be used for the real system with the fewer error. And one of the like a big issue in Korea too is Palantir. So Palantir is a US tool, so that is one of the like used for the like military service. And so of course actually like US versus Korea use this Palantir tool, and the Palantir is actively involved to the South Korean market in the manufacturing, so including the HD Hyundai, like apply this tool. So when you go to the like shipbuilding yard, and the Palantir tool is online, like gathering data from the like real-time robots from the field and the yard, and this data is well gathered and monitored and processed and for the AI system. So this Palantir tool, and also like South Korea use a lot of international tools, something like Palantir and AWS and other type of open source like a code, and this is one of the like a strong player and the driver for the South Korean like development. So we can say that this global trend will go for the different fields, something like manufacturing process optimization and energy efficiency and operation optimization and the predictive maintenance. So one thing is, so it is not generated from the scratch. So of course their strengths, they have a strength, and that they are building an application on top of their strengths. So something like Aspen, process mining, and the Palantir data gathering, and the GBA, like GE Aviation for the like optimization of engine and so on. So let's try to say something about in Korea in this regard. So South Korea has a different aspect in terms of manufacturing. So you cannot say the South Korean is the first, but of course South Korea is one of the like manufacturing like big house. So like we have a lot of big companies, something like Hyundai, LG, and POSCO and Samsung. They build actively the factory in the over the world. Something like Hyundai Motor Singapore Global Innovation Center is one of the best practice, recognized one of the best practice. And also we can see that LG Smart Park, which is one of the like World Economic Forum lighter factory, and the POSCO one. But one of the like a big headache or the thing that we South Korean government or like the company wish to improve is SME. So that actually government tried to improve building 30,000 smart factory like until 2023. And then like it is not really like, of course there are big, like there are some success to improve the procedure for the SME, for the mid-sized manufacturing company, and try to build a supplier for those company. But somehow, like many people and many like partners involved in the process and project say that it is not really 100% success. So there are something needs that we improved. Somehow, SME procedure try to getting the money from the government or public sector is not like getting big success. So somehow it is better to build the Korean model to lead those company like bigger, so somehow like build well. So in somehow, so South Korea tried to different approach, like global approach for the big company, and also improving the part for the manufacturing of the small and the medium-sized company. And also one of the things that recently South Korea tried to do is try to getting the best practice for individual domain of the like a thing, something like autonomous and electricity and the shipbuilding and like a second battery and machinery and steel making and semiconductor. The procedure are similar, but somehow their domain part are different. So try to like encourage the leader of the domain and try to catch the domain and lead the main role model for that procedure, and try to build the model, and then try to like a small and medium-sized company in that domain follow those model is what Ministry of Industry try to do. So you can see that South Korean manufacturing like strength is mainly strength in the fourth and so on. So you can see the China like rapidly become second one, and the Germany is like until the first one. Probably the rank, the first one changed recently, but somehow South Korea tried to like making the different model. So lead the company, not only for the build the lead factory in the overall world, but the lead the model in terms of software, data gathering, hardware, and the AI model, something like AI factory. And the government to try to build and invest US about 1.8 US billion dollar until 2013. So 30. So that is actually what recently South Korea tried to do. So South Korea has a lot of like a relationship between EU. Also, EU has building the quantum like co-funded R&D, and also EU invest big money for the AI gigafactory project. So many South Korean partners try to participate in the AI gigafactory project with other projects, something like Katana X and so on. And also we have Korea has a good relationship with Germany and the Ministry of both country and the PI 4.0 and LNI 4.0 and so on. So and the tech collaboration center between Fraunhofer and like South Korean side and so on. This is keep going. And especially like recently, the Korea-US side has a good relationship between KITTEC and the major US university, and the AI chip export control and the Boeing Center is what we are trying to do. And of course, actually, like we are like South Korea has a trilateral dialogue among the India and the US and South Korea for making the collaboration in the semiconductor supply chain, AI, digital infra, and so on. So we can try to getting the better collaboration in this sense, and the AI traffic monitoring collaboration, and the government level collaboration. We can make more government level collaboration, especially manufacturing side. As I say that India is one of the big house for the manufacturing, like in the global like hub. And as we can say that India has a lot of recently rapidly developing those areas, like especially the lighthouse factory has a lot of recent lighthouse factory in India, and also academic talent exchange also will be encouraging to make the long-term relationship between the industrial AI application between two countries. So we can say that these are really important. So the first, then the standardization interoperability is very important. Of course, we have a lot of systems, something like Palantir and the GMS, PLC, and so on. It is like important to keep discussing about standardize the data exchange in the manufacturing process and so on. And also like a stronger global competitiveness, and we need to have a better collaboration between one. No single country can lead all AI domain. So we can find the part of the AI, the South Korea has a good like one, and also like India has a good one. Of course, actually, if we go to the like very refined manufacturing process, then the South Korea has a lot of data. And also like some of the advanced AI technique because of a lot of R&D investment. And also India, strong historically a lot of good talent and like good people, so that would be good actually collaboration part. And also would be good find a new business model. So and would be good to share, and also it will help AI-driven smart factory will better make the better supply chain stability. And when we can reduce the uncertainty, if we have some good manufacturing part or relationship between Korea and India, even if there are something like happening in other countries, something like US and China and also Ukraine, then we may have some stability between India and Korea and so on. Especially that will be very important for the manufacturing procedure. So I will try to introduce some of the actual example that my company do for the South Korean company, and also for some Japanese company, like in the AI automation procedure. So what we provide this is the prediction system, as Professor Kuma say, and so our prediction is based on the multivariate time series data actually generated from the many industrial procedure. So that is not really easy. So somehow like it is a different type of problem for the with the LLM. So that what we try to do is we are trying to predict so the quality and quantity and the important variable of interest in the factory and predict and try to optimize. But that is actually not the final end. So we not only if we predict those value, but we also explain why AI system make that decision. Somehow AI system has a black box system, so it may not incorrectly learn the causal relation between the parts. So we can explain these, and then we can find and fix when the AI system make the wrong behavior or misbehave and something like. And also recently, because of the big change in the global market, the cost a saver is very important. So how much we provide the cost for the raw material and also fuel and so on, based on that our optimization point would be different. So even if we do the same steel making procedure, so how much we put the coal and how much we put the natural gas is different in the Japan and Korea, or probably in the China and also India too. So would be we have a different optimization point. So that is actually what this AI tool provide. So but as an example, not only for we provide a better practice, but so we have a deep tech deep technology in the explainable AI, which is better better estimation of the input attribution of the deep learning system than the Google, and also we have a world best prediction system for the multiple time series data. And based on this, and our company's technology is one of the selected as a national strategic technology, which is one of the first in this regard, and selected by government. And so the thing is, in the manufacturing process, South Korea spent a lot of money for the new technology, but also tried big effort to make these new technologies for the commercialized, industrialized in the real industry procedure and so on. Our company is one of these examples. So what we are trying to do is gathering the data from the production side, and previously, the human intelligence tried to operate based on the different actual scene and increasing the pressure and the lowering the pressure one, or change the temperature are by the operating by hand. But with operate reinforcement learning and explainable AI-based prediction system, our AI autonomously running those factory, not from the 100% from the beginning, but from the 10% and the 30% and 50% and 70% until the 90% and so on, then it will increase production and also reduce raw material and reduce energy cost, and the capability of handling operation with advanced AI expert and so on is what we are providing to the customers. So our system is provide to the steel making company something like CGL, and also glass making company, glass laminating temperature, and the cement industry something like kiln process, and the traffic signal, as we discussed, one of the cooperation item with Korea and India and so on. So you can see that steel making in hot roll process heating. So as operator operate these temperature manually, but now AI system automatically manipulate these temperature. And in the cement procedure, the preheater is operated by the AI more than 90%. And also in the refinery petrochemical system, so one of the largest a refinery plant is located in the Ulsan in Korea, and then we apply those to our customer and improve those productions. So this is one of the games. So in the CGL, so AI is automatically manipulating those procedure, and before then after we reduce energy usage and so on. And so major in the cement industry, if AI is automatically operating, the temperature change is actually reduced, as you can see in the middle of the image, and also reduction in the coal usage. And so that is also applied to the smart plant in the like a refinery plant, and it is saved. It automatically run the APC, Advanced Process Controller, and it saved 1.5 million US dollar per year. So for our customers. So the last one, so like we are, so the thing is, the global collaboration is very important. So if one system is built, so as I say at the beginning, so one of the competitiveness of South Korea is South Korean company try to install and use a lot of new technology from the outside, something like AWS and Palantir and so on. Of course, actually, the South Korean supplier is trying to getting to the global, something like Japan and the US and EU, and so also probably to India, and also we can help. So some of the good Indian companies to come to the Korea to compete or improve the procedure in the manufacturing procedure. Thank you.
Thank you, Dr. Choi, for the fruitful speech. As I mentioned before, so we have two presenters, and then after that, we will take a Q&A session. Following this, we will hear from Mr. M.S. Unikrishnan, CEO of IITP, Monash Research Academy at IIT Bombay. His topic is New Horizons in India-Korea Cooperation, AI and Semiconductor. Please welcome Mr. Unikrishnan.
Good morning, and let me take this opportunity in the beginning itself to place on record my gratitude to NAEK as well as INAE for availing this opportunity for me to be speaking to this august audience comprising of academicians as well as business persons from both the countries. Professor Jae-Sik Choi has already elaborated at length related to the way it is evolving in the world, and also the opportunities for cooperation between both the countries. Let me also thank Mr. J.D. Patil, who is also present over here, who is the president of INAE, and other members of both NAAK and INAE, and the business personnel as well as academicians present in this particular meeting. Now, I will try to be within the 30 minutes to give a picture, a different kind of storyline related to the evolving semiconductor and AI market of India, and the relevance of this topic at this juncture with the kind of tumultuous global trade positions prevailing. Without any specific PowerPoint presentations, it will be better to enumerate the situation as it evolved. And it will be pertinent for me to be dividing this into three specific sections, starting on with the past of semiconductor and AI in our country, and the present status and the way it is going to be taking shape in the world. Frankly speaking, when semiconductors got evolved in the world, with the rectifiers coming into being, we were still not an independent country. So somewhere immediately after that, our independence, only the rectifier was invented in 1948. And the first semiconductor factory of the world really came into being in Taiwan in 1987. Still, we were a country which had a lot of restrictions. We were an inward-looking, I would say that a society which believed in socialism, and we were not an open economy. We really opened our economy in 1990s. And of course, it had been a major advancement in every aspect of business development, human development index in India. In that, I need to also thank your country, Korea, for having partaken in multiple sectors, especially in electronics, as well as in energy sector, two of the areas where you really played a substantial role in helping India go up in the ladder in terms of economic development. Now, coming to what happened to India in the AI is current, but I'm talking about in terms of the semiconductor. The Indian market for electronic goods really lifted with 1984 when we had the Asian Games conducted in the country. And the government of India, despite being restrained in terms of capacity creation, allowed anybody and everybody to be setting up TV manufacturing in the country. And they were allowed import of anything, and just we needed to do assembly. There were 70 and odd licenses given, and multiple companies, virtually every industry, and anybody who could start an industry set up color TV manufacturing, but the entire components were imported. So we became a screwdriver technology related to semiconductors at that point of time. Though there were some second-hand plants imported into the country for making semiconductors, which are capacitors or maybe rectifiers equivalent of that at the early stages. But as the world moved at a faster pace, in my opinion, the real lifting of this has happened only with the advent of mobile communication, which came into being in 1990s. And we adopted it very well. In fact, I would say that with the kind of population that we had at that point of time itself, which was far excess of 1 billion, there is no way a country could have considered manufacturing all of them in India. So we allowed free import, not only of the mobile phones or components and later assemblies, even the mobile communication related back equipments were allowed to be imported at 0% duty. In fact, I mean, if you had import in 1990s or maybe early 2000s, Mr. Patil will remember about that. Even major technical engineering goods attracted the duties upwards of 20%. That electronic goods related to this was allowed to be imported at zero duty. But our intention was to make it available for Indians rather than creating capacity and creating technology. Maybe did we do a mistake? I don't know. But I can say that India has did a wiser thing at that point of time in terms of the software portion. The hardware we didn't focus on. We focused on Y2K and the software, which created some of the very, very large IT companies of the world today ensconced in India, operating all through the world. Very proud to say that industry today is almost sized at $300 billion, which is in excess of maybe the size of economies of many countries. So we focused on the software portion, did not focus on the hardware. I mean, no harm in that. Always there is a time for it. How this is the past of India. So we depended on countries for ensuring that even, I mean, I would say that a lot related to electronics, we did not, possibly we taught in our universities, but we did not practice that in the industry. But today we are at crossroads because the way things are changing in the world, everything will have semiconductors in the world. Without that, you cannot survive in the world. So I would say the drivers which are going to be making this substantial change in the need for semiconductors that is realized by India today, uh, which possibly is the largest population, and each individual in the country will be needing, is starting on with mobile. It is no more a mobile phone. That's the way we used it in late 90s for communication, a very expensive mode of communication. Evolved into beyond that level, it has got a camera embedded onto that. It has got then entertainment involved into that. It has virtually become a companion for a human being. And today it has become a partner of a human being. And proud to say that nearly 1 billion plus Indians do have smartphones in the country today. Nowhere in the world, including in the most developed countries in the world, they will not have a market of the size. And fortunately, unfortunately, all of them do depend upon IC wafers and the fab, which are needed in multiple levels. So India is a very, very large market. We recognize it that we'll be needing it. And with the advent of 5G coming in and 6G going to be coming in the next, maybe I would say that 4 to 5 year period of time where we'll be leading the world. Up to 5G, we were following the world. 6G onwards will be there in the cutting edge. So we'll be needing to support the hardware needed for the 5G communication going to be embedded onto this, where voice transmission will be a minor point of communication. It will be far too into pixels and 3Ds and a lot more into further live areas. And there I would say that it will be, I would say mobile phone will be more important than the life partner for a human being, not only for Indians, for everybody. In that area, we're looking forward to be developing. So that's one current thing which I need to be talking about. Second is a very basic television, which was maybe analog oriented in the beginning, which India gotten in. And I need to be again thanking your country, Korea, that both your large manufacturers of color TVs Samsung and LG did a wonderful job of ensuring that we were exposed to the better technologies, and you set up the manufacturing in India, barring for some components you had been virtually making in India. So that position is also very well defined, that today you are virtually the market leaders in the country in both these areas. And also in the white goods area, both these companies, apart from the semiconductor orientation, the white goods you introduced IT technology, IoT technology, and the most modern ones you've introduced over here. So there is already a pass available between our country related to both these items, mobile communication as well as TV I mentioned about. We were all used to when all of us started in the engineering education of ours. Well, I mean, it was purely an ordinary computer which is so heavy. Today, the machines that all of us carry in our pocket is maybe 1,000 times more processing capacity and memory storage, but miniaturized version, the laptops and the faster computing mechanisms available. Every human being in the country today will be having a computer, the miniaturized version, a mobile, combination of that. So that is another area where the market is exploding that way. And then comes the industrialization that India is. I mean, somebody, a colleague, a professor has already spoken about the EV. Well, it's not only EV, even the conventional diesel or maybe IC engine oriented one also today has got a lot more hybridization done, and all of them don't control, it's not controlled by a human being. I don't know whether we will go for autonomous vehicles, but certainly our vehicles are more automated going to be in the future. And the largest market for automobiles, which will have a lot more of embedded circuits prevailing, is going to be available. The next area is the health sciences, where the largest population of the world, where there are three factors that we are currently considering for the, Indian medical sciences. First and foremost, we will not be able to meet up with the hospital beds and hospital rooms for the entire population of 1.5 or 1.68 billion will be the peaking population of our country by 2060, where we'll peak our population, then we'll start coming down in that one. We are not planning for it. Converting our bedrooms into hospital rooms is a technology that we are currently identifying, and the Planning Commission, which is the Niti Aayog of the country, is already working towards that. So using AI and semiconductors in that area for diagnosis and visitation of the patient only to a hospital for the purpose of a procedure, rest will be at home. Pre and post is going to be happening with only semiconductors and communication combination. So that's an area which is evolving. Next item is that we're going to be moving into a personalized medication, because we are not wanting to waste medicines. Today, we realize that possibly of the quantum of medicines that is being administered by the medical fraternity to all our country and in the entire world also, maybe a 3 to 4 times more than what is needed for the human body, and the rest is being managed with the internal organs, which are again getting into a problem because of the additional medication or chemicals that we're pumping in. So that's an area where, as we are developing our medical expenses, we're not going to be following the rest of the world. We'll be possibly talking about personalized medication. And the last one in that area, bioscience, is going to be food as a medicine rather than medicine separately. And how do we administer it by having not genetic modification done to food, but ensuring that there is a combination foods which are not available today in the market, slowly started coming in nutraceuticals and bio-oriented ones, which we are going to be introducing. These are the kind of things which are going to be the movers for semiconductor industry, and AI also going to be playing a major role in that. We have a substantial advantage available as a country for the AI portion. Very happy to say that on an average, we produce nearly 1.2 million engineers in a year. Our admissions are in excess of 1.5 million. With a 300,000 failure or dropouts, we produce 1.2. And currently, we don't need even maybe a 10% of them for the manufacturing industry of the country. Going forward, that may go up by maybe 8 to 10% per year. So we have possibly, just look at your population, you have 51.8 million population, whereas we have 1.5 million per year getting into engineering. The largest technical force of the world who will be trained in AI or maybe related to IT is going to be from this country in the world. Let me be honest in admitting that they may not be of the quality that the world is needing today, but give or take with the kind of advancements that we are doing in our education mechanisms. Because our earlier, universities which were producing, fundamentally, I would say that teaching universities are now becoming researching universities. IITs have already become that way. In all the major IITs, we've got more PhD students than undergrad students today. And there are, 20 more of them in the waiting to be converting into that. NITs are getting converted. Give or take maybe a decade from now, you will have nearly 1,000 universities which have research capability, which is not available to anywhere in the world. So we'll be producing the manpower needed for it. So AI, we certainly are. If I had to give the numbers for it, virtually every IT company in India, whether small or big, has got half of their at least people working in the organization trained for AI. And virtually every company in India, which is in excess of 6,000 listed companies in the country, each one of them do have a task force for AI. So exposure is really happening. It is not only a development that I'm talking about, simultaneously application going to be done for AI, the largest market available for AI in that one. Of course, semiconductors are needed for that to be coming in. We possibly recognize that what we did in the year 2000 for managing Y2K with IT and forgetting about the hardware is not forgotten by India at this point of time. We have got a semiconductor mission, which had been able to be implementing projects worth nearly, I believe, around $11 billion so far. And currently in the offering are 6 manufacturing units for fabs. Predominant part of that coming in the state of Gujarat, one in of all the places Assam by Tatas, and Karnataka putting it, 6 of them already approved by the government of India, totaling an investment of around $51 billion. Well, it may sound to be very large for many of us, but let me be open about that. A classical fab plant will be needing a $10 billion investment if you to have an end-to-end to be created for it. My anticipation is that give or take maybe a decade from today, when the single largest semiconductor consuming market is going to be India, if that be so, there'll be another 10 to 12 larger companies going to be coming in the country. And there is currently investment muscle power available progressively developing. What we need is technology to create these plants. And that's a challenge that we are currently facing, which I'm going to come to, like what are the technology challenge that we have. So we'll be investing in this current move, both in AI, which in any case is very proximate to what we have done during 2000s. And it's something that we are training our manpower. And we are not going to train them for only India, because we believe in globe is a market, world is a market. The way we had done for vaccine time also, our intention was not to make money, making vaccine available to the world. Similarly, our attitude is that we'll certainly be having proliferation of the done in our country. We'll want it to be done for the rest of the world. Of course, we'll make a business sense out of that, but not the intention of wanting to profiteer from that. So that's something which you're already considering. In that, the challenge that we're facing also, I will talk about it. So this is the way, the current situation, and the companies already started. I'm in naming any one of them because it's available in the public domain. 6 of them are already, I would say the first Indian-made chip will be out by December 2025. It may have some components coming from outside, but come 2027, there'll be 6 manufacturing facilities working in India, producing for India, and part of them producing for the world. Because with the current geopolitical corrections happening, there'll be a lot more of market that will be open to India. So some of them may shut us, but some of them will be opening us for us also. And we should be able to supply to them the better quality, which is the modern one. In that, what we are seeking, let me tell you in the semiconductor portion beyond this, what you're currently seeking is, India did not develop the lithography technology, ASML technology that is needed for the manufacturing. Currently, of course, we are being provided with I would say the second generation, third generation machinery, but we will be, which can be at the best produce maybe a 90 nm to maybe a 25 nm can be manufactured over here. But I know that the world is already looking at 7 nm as a manufacturing production size for this one. We need possibly an EUV technology that is going to be an advanced one using ultraviolet to ensure that we are able to manufacture 7 nm. So we look forward to Korea. This is an area where, we need to be having, I'm sure government to government level discussions have to take place. But this is an area where we are looking forward to. You have the technology currently created. We are already being offered up to, as I mentioned, about 25 nm, which production is going to be starting. With minor modification, we are creating all the factories in the country which will have an ability to shift to maybe a 10 nm and later to 7 nm. And by the time the world will certainly be designing something of a higher nature. So here, this is an area where Korea and India can work together, because please remember, even if you produce it in any amount of billions of pieces, majority of that will be consumed by India, then China, then America comes. So if that be the case, it makes a lot of sense to to ensure that we have joint development of this machinery done for it, both EUV as well as this. And I would say that there is something common between Korea and India, which we need to be taking cognizance of that. Both the countries are not surrounded by friends. I will not elaborate beyond that. And I'm sure you will understand, we understand where we stand on that way. So we need to stand on our own feet, and we have a lot many people to feed than what you have. So we have challenges of a political nature, which of course will have to be moving cautiously, but you may be able to do it faster. But together, we will be able to ensure that without the support of the rest of the world, we had a 50 years of relationship with South Korea today. Without any skirmish, not even in a place where a comment is passed either by either country against any of the political dispensation. Not that political, clamoring doesn't happen in either of our countries, but we had been able to be maintaining a very stable relationship. So can we cooperate and support with each other? And that has got to happen with the INAE equivalent and NAEK equivalent, because the community of engineers, there is no borders for it. And since you're going to be faced with similar kind of problems, and you have a great market which is already proven. Your companies have come and set up manufacturing over here, and you can ask them, and I'm sure you guys are aware of the fact that how welcoming are we in the market openness and in everything possible that we equality provided. Of course, there are limitations that we have as a country with this kind of a population, but otherwise we have been welcoming, we'll continue to be welcoming. This is an area where we're looking forward to ensure that in the fab area, we have cooperation between both the countries, and fab capacity creation you will support, and we will develop along with you. And you are allowed to be manufacturing not only for India, for the rest of the world also you can do that. And I'm expecting that going forward, miniaturization is going to be the name of the game. Application in every aspect of manufacturing, though we may have a lot of population, but we are not looking at manufacturing in the future as people oriented. It is going to be mission oriented. So AI ML with Gen AI going to be taking charge of that also. We'll be at the cutting edge related to AI generation. So can we have the next level of fab being created together between both the countries is something which, as I mentioned about, so advanced semiconductor lithography, we look forward to having support or joint development for. Current machines can be bought by anybody by paying, but the future ones needed for it. And extreme ultraviolet lithography, that the UV which I mentioned about, we look forward to getting or developing it together with you. Clean rooms which are needed for today, we have knowledge available. We have created many with the support of multiple countries. But to get into the next level of 7 nm or anything smaller than, lower than, or stacking it further, we'll be needing next level of technology both in clean rooms as well as also for the inert gases. We have technology available for the clean room of today, or maybe in companies who are present in India, Linde or Inox, or maybe some of your own supporting companies will be able to create it. But for the future, we are going to plan for it right now itself. What are the blanketing requirement, clean room requirements for it? And then can we create that together? Next area. And the most important one where I need to be clarifying to you is that fab is only the fabrication unit. But there is a fabulous portion, which is the most important one. We have got design centers ensconced in a country for virtually every fabulous company on the world, utilizing the intellect of a country. But maybe they are doing pieces. They don't know how it is agglomerated or maybe put together, integrated into a finished product. This is an area where we are ready to invest as a country in fabulous to start on. You have the exposure to virtually every fab created. Some of the largest manufacturing in the world is done by your country only. I'm told that you are virtually going to be in the specialized area. You're aiming to be the number one in the world. So you have the fab knowledge available. So a backward creation can be done for fabless, which also is available to you, but may not be in comparison to a Qualcomm or an Nvidia, which is the talk of the town equivalent of that. Can we create the next NVIDIA equivalent of that between both of us put together? Our capabilities, knowledge, and the largest market available. But currently, it may not be needed much in India. But in my opinion, those kind of advanced chips are going to be necessary for India to address the market in the next 3 to 4 year period of time. Remember, currently we are possibly data dependent upon the developed world. Every Gen AI related data, I presume, is currently using the database ensconced in the developed world. But we recognize that there is also challenge for us to depend upon the data going to come from other country and the solution going to be created, especially with Gen AI and maybe LLM going to be taking place. We are very clear that we need to be having a lot more database of ours retained over here and developing using our database, the Gen AI for our kind of country. I would say Asia has got a different kind of a content requirement culturally, and lifestyle difference that we already have to retain that will be needed. So the government of India has already allowed 36,000 CPUs allowed for common use for innovators. Will multiply it as the requirement increases. And the government has also started a company for creating the internet data for LLM to be done for India using that. And the company just inaugurated recently in Bangalore. And the private domain, there's one more company which is set up as known as Kritrim, that is nothing but artificial, by Ola. So I would believe that in the next decade period of time, India will have its own Gen AI generation database available. So India-oriented LLMs will get created. And please remember, you will have data within your country for 51, 52, 55 million people. We will have it for 1.5 billion people. Now, many people use that as oil of the world, crude of the world. I mean, I don't want to attempt to be, too much ambitious about that. But be assured about the fact that virtually everything related to bioscience is related to the human being and anatomy and the diseases. All that which was available to India, we didn't store it over here. Give or take maybe 3 to 5 year period of time. If we could create UPI for the country, as an example for the world, we'll create our own databases also. So that will be accessible to you. So it makes a lot of sense for us to work together. And this is an area where I would say that the way currently Quad is currently working between India, Japan, and Australia a lot more in common technology development for defense services, defense applications, space applications. These are the highest levels of application. If you create that miniaturizing or maybe for the larger operations, it will be available in the industry. So can we have Korea and India working towards this? Something which we need to be debating at your country level, our country level, and together we are going to take it to both our governments. Can we have, not, these are not some 100 million initiative we are talking about. We're talking about between maybe can you have a plan of investing together $100 billion of, because India can today do that. We never did that earlier. When I mentioned about for a FAB plan to put maybe a $10 billion, 10.15 to be precise, Tata Group didn't even, battle an eyelid. They committed it that way. They already have 2 plants coming, one in Assam and one in Gujarat. Larsen Tubro, where Mr. Patil was working earlier, is already a fabulous portion created. I believe they already committed the first $100 million and willing to be committing up to $1 billion. So there are various Indian organizations willing to be getting into that. So can we work together? And then these are the challenges we'll have to give it to INAE, we'll have to give it to NAAK, to ensure that the research fraternity of the country in the academia, who will create the TRL 1 to 4, which can be taken to the industry together with you to next level to create manufacturing, and market is available here. And you can take it out of this place and market anywhere in the world, which you've done with automobiles, which you've done with electronics. I'm sure you will do also with semiconductors and AI. So that's my submission to you. And thanks a lot for inviting me and giving this opportunity to present India's case over here for the emerging opportunities. Thank you once again.
Thank you, Mr. Udi Krishnan. It seems we have no questions, so we will conclude this part. Thank you again, Professor Choi and Mr. Unikrishnan. We could find leading AI sectors in both countries, so we would like to find cooperation opportunities continuously. We now move to the roundtable discussion titled AI for Smart Manufacturing and Korea-India Cooperation. We are pleased to welcome 4 distinguished panelists: Dr. Kyungwon Ju, Korean Institute of S&T Evaluation and Planning; Professor Jung-hoon Mo, Department of Industrial Engineering, Yonsei University. Professor Santanu Chaudhary, Indian Institute of Technology, Delhi. Professor Rajalakshmi, Indian Institute of Technology, Hyderabad. This section, we will provide an opportunity to reflect on today's presentations and explore practical avenues for cooperation between Korea and India in the area of AI and smart manufacturing. Let's begin with Dr. Zhu. Please feel free to share your reactions to all the presentations, any personal insights or ongoing research relevant to the theme, or specific proposals for Korea-India cooperation. After Dr. Zhu, we will proceed in order with Professor Mo, Professor Chaudhary, and Professor Rajalakshmi. Each speaker will have up to 8 minutes. Panelists are also welcome to briefly respond to each other's points, and we encourage an open and engaging dialogue. Please, Dr. Zhu.
Is my voice rich? Is my voice rich? Hello, everyone. My name is Kyungwon Ju. I work on science and technology policy, especially for AI as national strategic technology. Before sharing my own thoughts, thank you for the 4 excellent presentations we just have heard from LG Electronics, Vice President Huang. We saw how AI can reinvent the smart factory by AI transformation in the real world. From IIT Kanpur Professor Ram Kumar, the talk on AI-driven logistics case study, it was really impressive to see how specific deep learning approaches are making an improvement in smart factory logistics. From INIGI, Professor Che clearly showed the latest global trends and real cases where AI was applied in practice and the measurable results it delivered. From IITP Monash Research Academy, Mr. Unikrishnan, thank you for sharing your perspectives, which added a valuable insights to today's discussion on global landscape and cooperation opportunities. When most people say AI today, they mean LLM models like ChatGPT, Gemini, or Grok. This is because they are very easy to use. Anyone can share their experiences with them. And people believe that help improve their productivity. In the past, we built AI model we called ANI, Artificial Narrow Intelligence. The roadmap seemed clear. ANI, and we get the AGI, Artificial General Intelligence, and finally ASI, Artificial Super Intelligence. But now, even though it's hard to define exactly what AGI is, but we are talking about vertical AI again. It's interesting cycle there from narrow to horizontal and now vertical again. This tells us something important. Even as AI becomes more general and powerful, the real value comes from the deep specialization. Manufacturing is a perfect example of this. We need AI that truly understands industrial process, not just general intelligence. So AI is rapidly changing, transforming the landscape of manufacturing across the world. From a IM policy and R&D planning perspective, I want to point out 2 important areas that are essential for making AI in manufacturing both impactful and sustainable. The first one is sovereign AI and governance. People may define sovereign AI differently, but may think about it in different ways. But few say we don't need to worry about it at all. At its core, it's about having control over the AI technologies that are crucial for your country. Recent global tensions have shown how important this is. Countries cannot depend entirely on foreign AI systems for their core industry. This is especially important for manufacturing, which is vital for economic security. In Korea, governance, we have established strong governance. There is a senior secretary for AI future planning in presidential office. This secretary and the Minister of Science and ICT came from industrial background, bringing practical experiences. And there's a national AI committee. This committee is a control tower to unify the country's AI efforts. This committee's primary function is to deliberate and coordinate national AI policies. This structure ensures coordinated policy making across government and industry. And second, I want to point out the role of public R&D strategy. Public R&D must focus on building infrastructure the industry can actually use. We need to bridge the gap between research achievement to practical applications. Investment should target areas where private companies cannot bear the full risk. So public R&D should support the development of AI platform for manufacturing. We need to create shared resources like data set or testing environment or evaluation tools. Training program also important for workers and engineers are essential for successful AI adoption. And collaboration between the research institute and the manufacturing companies must be strengthened. And well, that's all from me for now, and thank you.
Thank you, Dr. Chu. It's very impressive opinion about sovereign AI and public AI research and practical investment. Now move on to Professor Bo. He will deliver about the factory optimization, initial AI development, and the SME. Please go ahead.
Thank you for giving me a chance for having a chance to talk in a very interesting workshop between Korea and India. I enjoyed the 4 talks by the Mr. Hwang and also Professor Choi, Dr. Ramakrishnan, and also Ram Kumar. And firstly, I enjoyed the talk of Dr. Wang of LG. LG is one of the most advanced smart factory companies. And I had a chance to visit Changwon company 2 years ago, and it was quite fascinating. And also in his talk, he mentioned about the AGV with humanoid. And it's a quite interesting combination. AGV is getting very popular these days. And also humanoid robot is receiving quite a big attention after Jensen Huang's comment on MWC early this year. I would like to mention about it's quite a big challenge to have the humanoid robot in the near future, especially with respect to the data collection. These days, adopting AI requires a lot of data, especially good quality data. And the training humanoid robot requires quite big amount of good quality data, I assume. But I think the academia and the research needs to investigate on how to collect such data or generate such data for the humanoid robot training. I think it's a big challenge for them. That's one point. And the AGV is in the second talk, the Professor Ramkumar mentioned about a lot of AGV, and the AGV is getting very, very popular. And especially in LG, they have quite a big number of AGVs. And also Amazon, they have tens of thousands of AGVs in the company. And these days, the AGV is advanced to AMR, autonomous mobile robot, and which has intelligence. And controlling those two things, from the AGV to AMR, the control becomes centralized to distributed control. And I think the combination of the centralized and the decentralized control is needed because of the scalability issue. And it would be an interesting research question how to control tens of thousands of AGVs or AMRs in the company. And I think that's quite a promising direction for the future research. And there are a lot of mentioning on the AI in the smart factory and the industrial AI. However, accepting such technologies is not that easy. Even in the Korean smart factory companies, they decided not to accept such a certain solution. I would like to share one of my experience with the LG. The company tried to incorporate a scheduling solution using the reinforcement learning algorithm. But after 2 years of trial, they decided not to deploy that company-wide. And there are two reasons for that. One is the explainability. And the scheduler asked them to pick lot A instead of lot B. But the operator, after such a decision, they do not know why. And it is quite difficult for them to accept such a solution with the black box approach. That's one of the challenges that AI community need to solve for the such a scheduler needs to be incorporated. And the second challenge is the big cost of training. And when the machine does not operate or the breakdown happens, then they need to train the scheduler again for the changed environment. But in the company, machine failure happens quite often. And in such a time, the AI solution need to adjust such a situation automatically. However, due to quite expensive training costs, which may take 1 or 2 days, and such a solution is hard to be accepted. I know that there are certain areas that the AI solution is accepted, such as the inspection area, and those areas the AI solution becomes quite popular, but not all AI solution can be incorporated in the company in the future, and those areas needs quite a lot of research and the future work, I think. And the Dr. Choi mentioned about the Korean project regarding smart factorization of small and medium companies. And the Korean government spent quite a big amount of money for those small, medium companies to have the smart factory facilities. He mentioned that it's not a total success because of they did not get a good enough reasons. They spent a big amount of money for the first phase data collection, but the data collection is step one for the company to be smart factorized. And it costs a lot of money, but the companies cannot get the benefit of getting such a facilities. So the small and medium companies were not happy, even though they spend quite a big amount of money for those facilities. But the AI and those smart factory becomes beneficial after using those facilities. They can improve the productivity of those things. And I think the project of the Korean government was not 100% successful, but I think it becomes the basis for the next step. They at least have the sensor devices to collect such data. I think in the future we can improve the more for the productization. And also, lastly, I would like to mention the Korean and Indian collaboration aspect. India is becoming the production center of the world. I think we should start some co-pilot project between Korean and the Indian with the maybe a company like the Hyundai or Kia, who has the company in India, we can start some pilot project between Korean Indian researchers to start the smart project, small co-project, and that would be beneficial for both countries. That's it for me. Thank you for giving me time to sharing my idea.
Thank you, Professor Mo. It's very interesting points. I mean, about the humanoid and AGV altogether. And then we found that AI is not enough to apply very easily. Still, we have to resolve about the explainability and big training cost as well. But as Dr. Che mentioned, so we try to solve that part step by step, and then more AI algorithms can resolve the problems as well, I believe. Yeah. Next one is Professor Chedori. So he will share his perspectives on computer vision and the digital transformation in India manufacturing. Please.
Thank you. Let me first thank INE and NAEK for giving me this opportunity to address this August gathering. I've been lucky enough to work with Korean companies for a pretty long time, both Samsung and LG. And I have enjoyed the work culture of Korean companies, and I was also part of some of these Indo-Korean projects and the research initiatives which were there in the past. I think I completely support the idea that there should be an initiative between Korea and India to take up joint projects in the area of AI and smart manufacturing related to semiconductors. But what is very important, I would like to touch upon in this context is that in our entire discussions, possibly we have missed one point, that is of sustainability. Because semiconductor manufacturing, as well as even AI, both has a potential to generate huge carbon footprints, which is not good for the world. And there has to be an initiative to address that problem. We may not always look for large language models. And if you see globally, there are initiatives for small models, small multimodal models. And initiative in that context is also very important because sustainability is a global concern and not just that of Korea or India. So in this context, another point I would like to bring in on table in terms of smart manufacturing, the issue of prescriptive maintenance, because in India we find that particularly maintenance becomes a big issue. Lots of, I think we have financial loss because things are constructed, they are operated, but not really maintained. But even if we look at predictive maintenance, which is with the AI, we can have a pre-scheduled maintenance. But what is missing in the most of the cases is a prescriptive norm that how that maintenance should happen. And if you see today with generative AI, and we can have enough data about the possible options to do a maintenance and their consequences. Based on that, we can do counterfactual reasoning. In fact, the emerging area of counterfactual reasoning can help us to build a better prescriptive maintenance model, which can be also economic as well as support sustainability, because if we can extend the lifetime of all of these machines, we are saving the carbon footprint as well. The other important point is even with respect to these semiconductor processes, I think whether we get into real hardware or not, one of the open problem and one issue of interest to look at is creating digital twin of these process models and work with these digital twins to perfect the process to make the processes more efficient. And try to design the process in such a way, we know that many of the cases, it's truly, we need an automated, very high precision operations, but the drift in those high precision operations actually lead to the wafer faults and rejection of the lots. Now, therefore, bringing in the inspection and the preventive inspection in that process to making sure that precision is maintained and managed is an open problem, is a global open problem where I think since India is moving into the semiconductor space in a big way, and along with Korean companies, there can be joint initiative to look at it. The other important point is that when we look at this automation, the philosophy of automation can be different in Korea as well as India, because as we know, that our population is much bigger than that of Korea, and we have manpower to use. So the problem of smart manufacturing and complete automation really removes and reduces the human footprint in factories. But can we talk in terms of, which is very important today, is human AI collaboration? Not just AI-based things, but bringing human in the loop as a definite actor, which can also address the problem of lack of explainability and the robustness of AI systems. And that could be a different strategy altogether, and where India, with its skilled manpower, can contribute in a big way in operationalizing large-scale AI manufacturing processes. I think the opportunities are many for both the countries to collaborate. Korea has a certain level of technological maturity, and at the same time, in India, the intellectual maturity or the knowledge that we generate is also comparable. In fact, many cases, the many patents, if you see globally, are also being generated from India. I think this intellectual power and technology power should be converged through joint research initiatives so that the countries together can be a leader as a consortium, may not be always individual. Thank you.
Thank you, Professor Chedori. So you mentioned about many things about predictive maintenance and then digital twin for semiconductor and the importance of human in the loop as well. So tomorrow we will also continue about the semiconductor. So this kind of opinion could be very helpful. Yeah. Next one is Professor Rajan Lakshmi. Please go ahead.
Okay. Good morning, all. Thank you for giving me this opportunity to talk to you on AI initiatives at IIT Hyderabad. And I will briefly, give a small presentation about the autonomous systems that we are building at IIT Hyderabad as part of the project. So I'll just share the screen for that purpose. Sure. So basically, like under the, Government of India initiative on National Mission Interdisciplinary Cyber-Physical Systems, IIT Hyderabad, we are working on autonomous navigation technologies, where we are building a number of, autonomous mobility, particularly targeting the ground vehicles and area vehicles, that is drones. Okay, so actually the autonomous navigation technology, it is actually an interdisciplinary program, starting from, I would say, sensors, networking, mainly the most important, the artificial intelligence component, because it is completely autonomous, no human intervention. Okay, and then real time, because it is again real time systems being deployed in the field for mobility purposes, design, security, and when it comes to actually the simulation, safety testing, validation, again, the most important when we wanted to come to, product level development of, work on translational research and come up with products at higher TRL levels, it is very important that we do the testing and validation as per standards. Okay, so that it's also a very important component. And the most important, the next important component is again the management aspects, how to take the, product to the market from the business perspective. Okay, so this all different components are being integrated. And the most important, as I was saying, testing and validation requires, is the enabler for product development at higher TRL levels. Like when I say higher TRL levels, again, above 7, okay, and something around 9, which is actually ready for commercialization perspective. In that context, from the mobility aspect at IIT Hyderabad, we have a test bed at IIT Hyderabad, at around 10 acres of land have been, dedicated for this purpose, proving ground, different kind of test tracks are being, utilized for, is being built for testing and validation of autonomous vehicle technology. And this test bed is first of its kind in the country, where not only the ground vehicles, but also we can do aerial vehicle testing. Okay, when I say aerial vehicle testing, it is for drone development as well, autonomous drone development as well. Okay, so this is actually the aerial view of the test track. Okay, so we have been we have been hearing two different, speakers that, when we talk about autonomous or AI technologies, it is very important that a huge amount of data is required. So in that context, at IIT Hyderabad, we have been involved in a huge amount of data collection as well. So this is our exclusive data collection vehicle, which has, multimodal data. When I say multimodal, camera, radar, lidar, and position information. And this vehicle is, goes around the country collecting a huge amount of data, multimodal data set. Okay, so this is, around more than 10,000 plus kilometers of data have been collected so far on synchronized multimodal data set, which is very useful for creating the AI ML stack for driving purposes. Okay, so this is what, you can see, the data collection vehicle with different kind of, fusion, like radar and camera fusion, lidar and camera fusion, lidar camera fusion, or lidar radar fusion. Such kind of, fusion technologies can be created for autonomous driving stack development using this kind of data set. So this multimodal data set is being created, and also we use a number of, because a huge amount of data is being collected, the most important component is again the annotation and other stuffs. So we also use the AI ML techniques for coming up with automated, labeling tools. Okay, so these are some of the components. So having spoken about the data set, annotation, all these aspects which are very essential for the stack development. So we are involved in coming up with that, autonomous driving stack. So when I say autonomous driving stack, it is, starting from, sensor, multi-sensor fusion, okay, depending upon the requirement. It can be camera, radar, lidar, position, IMU, whatever sensors. Then, coming up with the perception stack, path planning, control algorithm. So this is the complete autonomous driving stack that have been completely in-house designed, developed, and optimized with different data sets. It's optimized on global data set like New Scene data set, Kitty data set, Waymo data set, and also we have created a lot of Indian data set also, including our own data set, and also triple IT data set. So the stack have been very optimally, trained on different data set, and it is also deployed on different category of vehicles. When I say different category of vehicles, you can see slow moving vehicles like, campus shuttles, which are already, in the autonomous mode, flying in the campus itself, and to heavy, to high speed vehicles like, commercial M1 category vehicles. So this is the complete autonomous driving stack, and as I was saying, in the campus at IIT Hyderabad, the autonomous vehicle have been already deployed since August 2023. Okay, so where we have been, flying the, rendering this autonomous vehicle service from the main gate to the, this is the main gate to the academic zone, which is around 3.5 kilometer, and so around 4 services in the morning and 4 services in the afternoon, and response to the environment, and it has ACC, AEV integrated as per the standards. Okay, so this is a very important achievement, I would say, completely in-house design technology from the complete end-to-end autonomous driving stack development. The same thing we have been actually deploying in different kind of government organizations as well. Okay, so this is again moving forward, now we are working towards large language models or foundation models. That's where, now we are trying to also see how this intelligence can also be integrated in the edge cloud kind of scenarios. That's where, we have the edge cloud and 5G/6G kind of setups, which can enable foundation models being integrated into the autonomous driving stack. Similar to the ground vehicles, we also have autonomous flight stacks where different kind of drones are being developed as part of this. You can see starting from some of the bio-inspired activities to medium scale activity to heavy payload drone activities, different kind of applications. You can see some kind of swarming applications are being developed with autonomous flights. And these are kind of beyond visual line of sight. When I say beyond visual line of sight, especially it is useful for drug delivery kind of applications. Okay, so this is being again the autonomous flight stack can accommodate this kind of application. The most important is GPS denied or kind of strategic applications where it's for indoor kind of navigation, where again a lot of AI ML stack with multimodal sensor fusion for navigation purposes. Okay, so these are certain kind of again drone activities and autonomous flight activities that we do. We also work on heavy payload category. When I say heavy payload, like personalized air vehicles kind of applications as well. So these are briefly what we do, and we work a lot on contributing to standards as well, for in terms of AIT standards, or in terms of participating in discussions for urban air mobility solutions with DGCA. Okay, so in some sense, multimodal transportation, the autonomous navigation technology supporting multimodal transportation is the primary focus at IIT Hyderabad as part of the hub. And yeah, so this is briefly what we do at IIT Hyderabad, and we see a lot of scope in terms of AI being utilized for this kind of mobility applications. Thank you.
Thank you, Professor Rajalakshmi. You introduced about the test bed for autonomous navigation. It includes sensor, AI, safety, security, simulation, all the things. And then not only the autonomous navigation, but also it could be used for smart manufacturing as well. So we hope we can have a chance together. So this is the end of the panelists. So if you have a question each other, please let me know. Then yeah, there's no questions each other. So I'd like to conclude this session. Thank you for all the thoughtful contributions and for the looking ideas. Today's discussion has highlighted not only the potential of AI and smart manufacturing, but also the strengths of collaboration between our two countries. Let us continue to build up this momentum and work together toward practical and impactful initiatives. We hope this roundtable served as a springboard for deeper partnership and sustained dialogue. Thank you again to our esteemed panelists and everyone here for the participation. And then there is a question in a chat box, but it is related to semiconductors. So tomorrow we have a semiconductor session, so we will answer in that part. So let's now conclude this session. And this is the end of today's schedule. So I'd like to conclude the first day of workshop. We thank all speakers, panelists, and the participants for your contribution. And we look forward to seeing you again tomorrow for session 2 on semiconductor manufacturing and fabrication collaboration initiatives. So thank you all again, and then I'll see you tomorrow. Thank you very much.
Thank you.
Recording stopped.